Hello and welcome back. In 8.1, we get to work with right triangle trig. And specifically, we get to play with some applications as well. So consider acute angle theta. So we're going to assume that this is in Q1. So here's our acute angle theta. We're in Q1. So we have the adjacent side to the angle, the opposite side to the angle, and the hypotenuse. Adjacent squared plus opposite squared is hypotenuse squared. So sine theta, we have defined it as y over radius before. We can also generally think of it as opposite over hypotenuse. Similarly, cosine theta would be adjacent over hypotenuse. And tangent theta then is opposite over adjacent. And we have their reciprocals as well. So cosecant of theta then would be hypotenuse over opposite. Secant theta is hypotenuse over adjacent, and cotangent adjacent over opposite. So the first application they have us working with is optimization. So here is a river. And we have 40 feet of fence to run parallel to the river. And then we have two other 10-foot sections. And we're going to make this angle theta. We're going to find theta to maximize the area. And of course then find the max area. Now with calculus we can get exact value solutions for this. With trig, we're going to have the calculator help us with some approximations to the solutions for this. So I'm going to break down the drawing a little bit. So here's our 40 feet. And we'll make just a nice little right angle there. So if this angle is theta, and remember the river and the fence were parallel, then alternate interior angle says this is also angle theta. So that would make this the adjacent side. And this one the hypotenuse, which is 10 feet. And our vertical side will then be our opposite side. And we have sort of an identical figure happening over here. So alternate interior angles of parallel lines are congruent. So if this guy was theta, that guy is also theta. So here is our adjacent, our opposite, and our hypotenuse. So then our area, 1/2 times the base times the height for this first triangle. So just this much of it. So our base is the adjacent side. Our height is the opposite side. The middle we have a rectangle, so that's 40 times opposite. And our last triangle is also 1/2 times base adjacent height opposite. So then that's where the trig comes in to help us out a little bit. So the cosine of theta, recall, is the adjacent over the hypotenuse, but we know the hypotenuse. The hypotenuse is our 10 feet. So cosine theta is adjacent over 10. So the adjacent is 10 cosine theta. Similarly, sine of theta is the opposite over the hypotenuse, but we know the hypotenuse to be 10. So sine theta is the opposite over 10. So the opposite is 10 sine theta. So by substitution now, our area is 1/2 times our adjacent, so times 10 cosine theta, times our opposite, 10 sine theta, plus 40 times our opposite, so 40 by 10 sine theta, plus 1/2 times our adjacent, 10 cosine theta, times our opposite, 10 sine theta. So a little bit of cleanup here, 150, so we have 50 cosine theta sine theta plus 400 sine theta plus 50 cosine theta sine theta. And just a little bit of like terms there. So 100 sine theta cosine theta plus 400 sine theta. So we're looking to approximate this. So in our calculator here, we'll go to our y equals, and x is going to take the place of theta. So 100 sine x cosine x plus 400 sine x. And there I missed the last one, so second and insert, so I don't have to type everything over again. 400 sine of x. And we're looking to maximize this. Now we said theta is an acute angle, so we know it's between 0 and pi over 2. So that's what I'll set up our window as for the x's. A min of 0, a max of pi over 2. So we'll set the scale at maybe pi over 4. You can set it to pi over 8 if you'd like. Y min, our area has to be at least 0, and our y max, we can kind of go to the table and find out. All right, so we have at 1, we have a value in the 380 range. All the way to 3, but 3 is more than pi over 2, so we're not worried about that. So we'll top it out at maybe 400, and if we have to move it up, we'll move it up. So y max will start at maybe 400. We'll count by 40 at a crack, change it if we need to. So here comes our curve. And it looks like it does just kind of miss the top. So we'll move the window up again, maybe to, we'll set it to 500, and we'll count by 50s then. So these outputs are the different areas based on an input value of x in radians. And now we can see a peak value. It's somewhere in there. So second in calculate, we want to estimate the maximum. They'll ask us for a left bound. We move that cursor until it's sort of in the neighborhood by the top value. Hit enter. We're just narrowing the search area. All right, so the values are coming back down. Enter there, and it'll ask for a guess. So theta, we'll just approximate it. Theta is approximately 1.344 radians. And our area is approximately 411.667, and that is in then square feet. Since the original was in feet, the area would be in square feet. So the next application we get to play with, the idea of complementary angles. We have sides A, B, and C. C opposite the right angle, theta opposite B, and phi opposite of side A. Since we're in a right triangle, we know that theta plus phi is worth pi over 2, or 90 degrees, i.e. they are complementary angles. So sine of theta, sine is opposite over hypotenuse, so B over C. You might notice that the cosine of phi, though, if phi is our angle, the adjacent is B, and the hypotenuse is still C. So sine of theta is equal to cosine of phi. Cosine of theta, cosine would be adjacent over hypotenuse. And notice sine of phi, opposite of angle phi would be angle A. Hypotenuse is still RC. Those two are equal to one another. So tangent of theta, opposite over adjacent, B over C. So notice that's equal to the cotangent of phi. Cotangent would be adjacent over opposite. My apologies, adjacent over opposite. I'll give that one up. My adjacent is A. My apologies, I don't know where the C came from. Now, if the originals are equal to one another, the reciprocals then would have to be as well. So, for example, cosecant of theta would equal the secant of phi, and so on. So we can use these to do what they call solving a triangle. Specifically solving a right triangle. We have angle A, angle B, and angle C. We will default to the right angle, and lowercase a, lowercase b, lowercase c. So capitalization does matter here. Uppercase, we're talking about an angle. Lowercase, we're talking about a side. So if you do have that habit of writing them all one way or all the other, you're seeing the same letters appearing in upper and lowercase and having different meanings. So make sure you're aware of that on this. So some properties that we know: a squared plus b squared is c squared. Our friend Pythagoras still applies. And cap a plus cap b is 90 degrees, which is pi over 2. So we can use those to solve a right triangle. So for example, they may tell us that, for example, c is worth 20, cap a is 40 degrees, and basically solve the right triangle. In other words, find all of the remaining angles and sides. So we'll draw it. So right angle is always C. We'll put our A and B in there. So our A is 40 degrees. A and B are complementary since we're inside of a right triangle. So B has to be the remainder, which would be 50 degrees. So the three angles together add up to 180 degrees. The right angle takes up 90 of those degrees, so the remaining two have to add up to 90 as well. So B is worth 50 degrees. They also tell us that side C is worth 20. Well, that's enough to find the rest of this. So here's side A, here's side B. So I can say, for example, then that if I'm looking for A, that the sine of 40 in degrees is worth A over 20. So A is 20 sine of 40 degrees. If they give you one in 40 degrees instead of radians like we usually work with, just make sure you temporarily switch modes in your calculator. So our mode, I'm temporarily going to switch it from radians on over to degrees. I just have to remember to put that back to its usual state when I'm done. So then 20 sine of 40 in degrees, approximately 12.89. Or my apologies, we're not getting 89, 85575, so approximately 8.56. And again, that's not the only way to have gotten there, since we also know the measure of angle B. So side B is our only remaining thing to find. So I can do cosine 40 degrees is worth B over 20. So B is 20 cosine 40 degrees. And we're already in our sort of temporary state of being in degrees rather than radians. So B is approximately 15.32, and 08 will round up to 01. Okay, so next one, they'll just give us two of these sides. So same direction, solve the right triangle. This time lowercase a is 6, lowercase c is 14. So you always want to make a quick sketch of it. So here is angle C. side C is 14. Angle A, side A. Angle cap B, side lowercase b. So lowercase b we can find just with Pythagoras. So b squared plus 6 squared is 14 squared. So b squared plus 36 is equal to, I think that's 196. Let me double check that. Yeah. And then minus 36. And we're at $1.60. So b squared is 16 by 10. So b is 4 root 10. So we have our side b, 4 root 10. And then we can get our angles out of this. So for example, the tangent of A is then 6 over 4 root 10. So A is the arctangent of 6 over 4 root 10, or the arctangent of that would be 3 root 10 over 2 times 10. So arctangent of 3 root 10 over 20. On this one, just make sure that you're closing the parentheses appropriately. So arctangent will open a parenthesis for you. 3 square root of also opens a parenthesis, so we're closing it up after the 10. We're letting the calculator know all this stuff was grouped together, and then dividing by the 20, we're letting it know it's done with the arctan. So angle A is approximately 25.377 in degrees. So then B, we can either use the complement or we can do a similar argument with B. If we do the complement, 90 minus our last answer, and we get 64.623 approximately. All right, so sort of a classic application problem for these right triangles, height of an object. All right, so you also get to see some more of my awesome artwork. So there is my stick figure's noggin there. And there's his little arms and legs. We'll assume his eye is at 6 feet. His or her, I suppose. And we're looking at a tree. Beautiful tree. Can't you just see it? You can really see the tree there. All right, so here to here is, we know, 6 feet. If I'm looking straight across, and let's say that we were 50 feet away. We measured 50 feet away from the tree, and the remainder of the tree, we'll call that X feet. And the angle of elevation to look at the top of the tree was 25 degrees. Okay, so we know things about the adjacent. We don't know much about the hypotenuse. We do know that we're looking for this opposite side, and we know the angle. So that should say we're working with tangent. So the tangent of 25 in degrees is worth the opposite over the adjacent side. So the rest of the height of the tree would be 50 times tangent of 25 in degrees. So 50 tan 25. Again, making sure you're still in degrees temporarily. So x is approximately 23.315 in feet. That is not the height of the tree, though. Don't forget that. That is how much over 6 feet the tree is. So the tree is approximately 29 then, 0.315 in feet. So just add 6 feet to the measurement of x. So then one other idea we look at in this section is the idea of bearing on a compass. So here is our due north, west, south, and east. So when they're doing compass bearings, a measurement like this one here, this would be approximately north 10 degrees east. So they're saying go north and spin it 10 degrees east. Or back here would be north 45 degrees west. Or something over here, I could say that this is south and then turn 80 degrees east. So I'll have an object. Starts at 0 on bearing north 20 degrees east. So kind of similar to this one. And we do that for 10 miles. Then turns 90 degrees to the northwest. We'll draw this in a moment. And does that for 50 miles. What is the new bearing from 0? So first, we'll sketch it out. So north 20 degrees east be in quadrant 1, so to speak. So basically, here to here is a 20-degree angle. Then we took a 90-degree turn in the northwestern direction, so headed this way and made a right angle out of it. And we did that for 50 miles. And we want to know our new bearing. So what we'll do is temporarily make this whole angle theta. And we know the adjacent, we know the opposite, so tangent will be involved. So tangent of theta is equal to the opposite over the adjacent. So tangent theta is equal to 5. So theta is the arctangent of 5. So theta is approximately 78.690 degrees. But remember, 20 of those degrees are used up going in a different direction than our bearing from 0 here. So I'll take 20 degrees off of that, and then the new bearing 58.690 degrees. And that would be then, we're now north and west. So that tells us we would report it as north 58.690 degrees west. This would be our new bearing. So obviously not to scale here. You can see that my 10 and 50 were drawn approximately the same size. Okay. So in 8-1, I would recommend 9 to 41 on the odds, 49, 51, 57, and 63. If you have questions, please get in touch with me. Otherwise, I will see you next time. Thank you.